Hi, I'm Joseph Binkin,
And I'm Dawson.
and we will be presenting artificial intelligence and creating consciousness, and then we will be relating that to existentialism. So, artificial intelligence seems like this wacky sci-fi thing that you see in movies like Terminator, like Skynet and all that, but it's actually becoming a reality, especially in the past few years. It's becoming so much of a reality that even global leaders are talking about it. Putin recently came out and said, and recently, like a few months ago, he said, artificial intelligence is the future, not only for Russia, but for all humankind. It comes with colossal opportunities, but also threats that are difficult to predict. Whoever becomes the leader in this sphere will become the ruler of the world. And not even that, but actually, the UN will be voting soon whether to ban autonomous weapons or not. And actually, of course, Russia said that they're not going to be voting yes on that, and that they want to continue making or researching autonomous weapons. So there's that too. So a recent development in artificial intelligence research is Google's DeepMind AlphaGo, and this is basically what this is that there's this game called Go. It's a 3,000-year-old game made in China, and players take turns and place black and white stones on a board, and they try to capture opponents' stones or surround the empty space to make points of territory, sort of like chess. And it sounds really, really simple, but it really isn't, because there are actually 10 to the 170 possible board configurations, and that's more than there are actually atoms in the universe. And another thing about this game is that little logic is actually involved. Players actually use feeling to place stones on the board. And that's why this game is super interesting and super complex. And you wouldn't think a computer would be good at it, only humans. And past AI that people have made used search tree algorithms, and this didn't really work out super well. And the best people could beat were only amateurs. You go higher than an amateur, and it just completely fails. They beat it in an instant. But Google's DeepMind AlphaGo uses neural networks, and I'll be going into neural networks a little bit later. It uses neural networks to play itself over and over and over again, learn from its mistakes, and then improve. And so last year, and you probably heard about this because it was huge news, because it wasn't supposed to happen until I think 2020 or 2030 or something. AlphaGo beat Lee Sedol, the world champion in AlphaGo, in a 2-to-1 match, and that's completely unheard of. And then an even more recent development is this bot that Elon Musk's company, OpenAI, made for a video game called Dota. And it did the same thing, where it played itself over and over and over again, learned from its mistakes, and then played the best people in this video game, in a 1v1 match. And it actually stumped these players. It was so good that it even made a new move that these players never seen up before, and they're actually adopting that new move in after playing this game. So a question for you guys is, how far do you think artificial intelligence will go? Do you think it's just some weird sci-fi pipe dream that isn't going to get anywhere, or do you think it will actually become a huge reality, or maybe even something bigger? So this is what it feels like to be here right now in 2017. Where you have this really gradual growth from the beginning of human civilization to now. And this one professor of computer science and mathematics at San Diego University, who was actually really big in the artificial intelligence field around the 80s, he said that we are on the edge of change comparable to the rise of human life on Earth. So basically that means artificial intelligence is going to be this huge thing, and we're right at the edge right now. And then once we get over the edge, it's going to feel like this, where you're going to have this huge parabolic growth. This is called the law of accelerating returns. This is what philosopher and computer science expert Ray Kurzweil calls it. And basically it just means that more advanced societies have the ability to progress more than past societies, just because they have more technology, they're not smarter, but more experienced and more knowledgeable. And because of that, they can just progress faster. He also predicts that the 21st century will progress 1,000 times as much as the 20th century. So right now what we have is called ANI, which stands for Artificial Narrow Intelligence. And this is really simple AI, what you find in computers that can play chess, which is also in that picture right there was actually the first chess playing computer, but not really, because there's a guy hiding inside that box. But anyway, you have things you have ANI in cars with anti-lock brakes, fuel injection systems, self-driving capabilities. You have stuff in phones, you have the weather app. That's an ANI system. You have Siri, which is obviously an ANI system, or even something like Pandora and Spotify, where like tailors your taste in music for you. That's an AI system. Even like your email spam filter, that's an AI system because it uses that like same like feedback mechanism where it kind of like caters what emails are for you and which ones in spam. Also, you know that creepy thing with like Facebook where it, like gives you like suggested friends that are like in your area. That's also an ANI system. Same thing with like those Amazon recommended ads where you like see on different websites. ANI system right there. Google search. And also like things like there's really big ANI systems in like the military industry or manufacturing or finance. Actually, the 2008 or 9 flash crash was caused by an AI error where I think it was like 13 billion or maybe even trillion dollars were like lost because like this AI system like messed up. Luckily that was like it was like fixed within like a few hours and everything, so it wasn't like that big of a deal. But yeah. And then the next category you have is artificial general intelligence. And Professor Linda Gottfredson says a very general mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. And basically she's defining intelligence. And basically what AGI is like the equivalent of human intelligence, maybe even consciousness. AGI, or an artificial general intelligence, would basically be as smart as a human and could do everything that a human could do. With regular ANI systems, those things are like really, really niche. Like you can ask Siri like, hey, can you Google this for me? But you can't ask Siri like, what's the meaning of life? Or describe to me like if that's a cat or a dog or something like that. It can't reason, it can't think beyond like what it's programmed to do. And then there's ASI, which is artificial superintelligence. And Nick Bostrom, who like Ray Kurzweil, is another like computer science expert or artificial intelligence expert and philosopher. He's actually a philosopher at Oxford. He says that ASI is an intellect that is much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. This thing would be like omnipotent. It would be like greater than God almost. It would like know everything. It would know more than everything. You could ask it anything, it would give you the answer like within a second. Or you could even ask it to solve problems for you, like huge problems, and would get it done within seconds. This thing would be insane. So here's another question for you. We have artificial narrow intelligences, ANIs, right now. Do you think AGI could ever be possible? Do you think ASI could ever be possible? So that's an interesting thing to think about. And here's another interesting thing to think about. Computer scientist Donald Knuth, he says that AI has now succeeded in doing things essentially everything that requires thinking, but has failed to do most of what people and animals do without thinking. Basically what he's talking about is that you take a computer, even a calculator, your phone, whatever, you can multiply huge numbers in a second. That's really easy. We already figured that out. We figured that out like decades ago. But to distinguish a cat versus a dog, that's incredibly hard. We haven't figured that out yet. Actually, I believe DARPA is working on something like that, but they're far from getting that figured out. You can get an AI that beats a human at chess. That's super easy. We have that done. We got that figured out. All right, but it's really, really incredibly difficult to make an artificial intelligence system that can read a paragraph from like a 6-year-old's picture book and not just recognize the words, but also understand it. That's incredibly difficult. Actually, Google is also putting in billions of dollars to figuring that out. Once again, calculus, financial market strategy, language translation. That's not mind-numbingly easy for a computer. But what's really hard is like vision, motion, movements, perception that you do without thinking. And like for humans, we've had like billions of years to evolve our like brain software to like do vision, motion, all those things without like even thinking about it. So that's what Donald Knuth says when he says like AI has now succeeded in doing like everything that requires thinking, but other things that don't require thinking. And to be human level intelligent, a computer would have to like understand things like emotions, like facial expression, joy, sadness, just all these different emotions, which is also kind of like what consciousness is almost about, like being aware of yourself and your emotions and everything like that. We'll get more into that later. But to kind of give an example, because this might be hard to wrap your head around a little bit, to kind of give an example of like what this means, if you look at this box with like these gray like squares shaped in a bigger box, right? You can tell what that is. So can a computer. It's looking at all the different like shade differentiations and it's able to like see like, oh, like, yeah, it's like this like weird rectangle with like gray boxes that's made out of it. But then if you reveal the rest of the picture, you have like all these different shapes. You have like these cylinders, you have like these weird like cube things, more cube things. It's just like a bunch of weird shapes, right? You can tell what that is. A computer can't do that. It just sees different shades of gray. Another example of this is look at this black rock right here. You instantly, you don't even have to think about it for like more than, or even less than a second, like it's a rock, right? A computer will just see just different shades of gray, different differentiations of gray, and be like, okay, yeah, that's black, that's gray, that's white, but it can't say like, oh, this is a rock. It's not aware that it is a rock. So that's another, or that's like the same big thing. We can make computers do like these really complicated things, but we can't have it like, it's really hard to make like an artificial general intelligence. And another thing about that is you also can't make AGI without increasing computational power. It's one thing to code it, but another thing is to actually have the power to do this. And what this graphic here is representing is Moore's law, which basically what Moore's law is saying is that computer power doubles every 2 years. In 1985, you had a computer that ran at the power of a trillionth of a human brain. 1995, a billionth. 2005, a millionth. 2015, 1,000th. Right? So every like 10 years, we get closer and closer to like getting to the computational power of a brain. And also, what this graphic shows is like in like 1900 to like 1980, we didn't have like any computing. Like the most powerful computer we had was like had the power of like one insect brain, and like each year we're getting closer to like one mouse brain, and then it says right here like by like 2020, like 2030ish, we'll get to like one human brain, optimistic estimates. And then after that, by 2040 to like 2060ish, all humans brain. That's Moore's law. See that parabolic exponential growth? That's what that is. And so like right now we have the world's fastest computer. That's in China. It's called the Tianhe 2 or something like that. And it actually beat that number. It has 34 quadrillion computations per second, but it's huge and uses so much power. It takes up 720 square meters and uses 24 megawatts, while the brain is just 20 watts. And it also costs $390 million. So right now, the raw power for an artificial general intelligence system, it's available right now. But hopefully within 10 years, we can make it more affordable, use less like electricity, and have it use more raw computational power. And then another thing we also have to think about right now is with artificial general intelligence is making it smart. And we have 3 ways to do this. We can either plagiarize the brain, simulate evolution, or make this whole thing the computer's problem and not ours. Basically, with plagiarizing the brain, we're trying to reverse engineer the brain. And once again, the optic estimate that we can do this completely by is 2030, but that's like super optimistic. But once again, we also got AlphaGo working in 2016 versus like 2020. So one example that what we're trying to do right now, and I mentioned this earlier, is neural networks. And basically how neural networks work is you have like these transistors or transistor neurons, and they work exactly like neurons. They're connected with like inputs and outputs, and it knows nothing, almost like an infant brain. And it learns a task, and it does it completely randomly. But when it gets something right, it's told that it gets something right, and those connections are reinforced. And when it gets something wrong, those connections are weakened. And so like after a lot of like trials and feedback and stuff like that, the neural network by itself has formed like a neural pathway, and it's become optimized for like the certain task. And then another way we can plagiarize the brain, which is like even more sci-fi. Actually, that last thing isn't even sci-fi. That's like what we have right now. But one thing that we have right now is whole brain one thing that we want to have is whole brain emulation, where we can scan the brain into slices, into like different layers, and then 3D model it and integrate it into computers. So like if someone dies, you can like scan their brain and then like have that person become a computer almost. If plagiarizing the brain doesn't really end up working out, we can simulate evolution almost, where we take different like algorithms or AIs or whatever and try and optimize them for a task or maybe even consciousness or something. And basically, whenever they're like closer to optimizing or to getting the task done or like getting closer to consciousness, you merge their programmings together or their codes together, almost like how you have like two parents and they procreate and something like that. But the problem is, real evolution took billions and billions and billions of years, right? This we could actually just kind of like control more because we could like set the boundaries for it. We can like actually kind of like say like, oh, this is what we want. Evolution works super randomly. Like evolution, like you get like random wings or legs or other things, and we'd want intelligence. Sometimes even in evolution, like intelligence is completely like selected against because it takes up too much energy. In this case, we would be going right towards intelligence. So yeah, and so I'm going to show you some examples of neural networks right here. I'll make this super fast for you. Basically, what I was mentioning earlier, it started without any knowledge whatsoever and then taught itself how to walk. And like in this case, even like when we're talking about consciousness, it has to be aware of itself and aware of its surroundings, like know like what's happening, what's going around, going on. So I'll show you another video right here, which is using another neural network where they pretty much like simulated a earthworm's brain using a neural network. An earthworm only has like 370 neurons versus the brain, which has like billions or trillions or something like that. So it's like super easy to like simulate, and it's kind of like the same thing right here. I'll speed this up again. So it's receiving input, and like these neurons are stimulated, and then it's given an output the same way like an earthworm's computer or brain, kind of like a computer, kind of just like works around, and it's acting as if it's like an earthworm. This thing is working completely by itself. And once again, if you could kind of simulate the human brain, it would have to be conscious of its surroundings and of itself. It would work in the same way, just be more of like a digital brain, digital neurons, but it would still work completely the same. It would abide by the same laws of physics that the human brain does, and it would probably be almost as conscious.
So you're probably wondering, how does AI connect to existentialism? Well, as Joseph was talking about earlier, technology is growing at an exponential rate, and we tend not to think about how fast it's actually expanding. We are living in a world where a computer is being the world champion at Go, which is a game based on feelings. That should alarm us. Are they coming to a time where computers are developing feelings? If a computer has feelings, is it conscious? The concept of consciousness is one of interest to existential philosopher Jean-Paul Sartre, who is most famous for his writing Being and Nothingness. Jean-Paul Sartre defines consciousness as one being self-aware. We can see elements of self-awareness in Google's DeepMind. As shown earlier, a neural network is self-aware of its surroundings. It is able to detect obstacles in its path, and it finds a successful way to avoid them without failing. This breakthrough in technology can be the pathway to creating consciousness and artificial intelligence. The question I have for you is, how is artificial intelligence even possible to acquire the capabilities of self-awareness? Artificial intelligence is actually learning by plagiarizing the brain. Let's look at an example. In the top right corner, we can all see the letter B, but a computer would recognize the letter B as a pattern of different shades pixel by pixel, and it would take random guesses at what this letter is, depending on the pattern of the pixels. After finally guessing correctly on the letter B, the computer will recognize this particular pattern as the letter B. The computer has to do this every time it wants to learn a new letter through a process called trial and error. The computer is plagiarizing the learning process of the human brain. A neural network was able to learn the game Dota 2, and it was also able to beat the world champion in it, with moves that have never been discovered before. The world champion, Dendi, forfeited future matches with the computer, and was amazed by the fact that it was able to outplay a human. He said that the bot felt like human, but also felt a little like something else. If artificial intelligence is capable of learning a game and also being the world champion in it, is it capable of developing consciousness? As we discussed earlier, Jean-Paul Sartre defines consciousness as one being self-aware, and we saw elements of self-awareness in computers through Google's DeepMind. And we also discussed that if something is capable of being self-aware, it also must be capable of having learning capabilities. So if a computer is able to have self-awareness and learning capabilities, I believe that soon a computer will be able to develop a full-functioning consciousness. Jean-Paul Sartre believes that to truly exercise good faith, one had to be aware of their own self-conscious by recognizing themselves as the reflected subject and the subject doing the reflecting. So for example, when we look in the mirror, you know who you are, and you know that you are a human existing. Sartre believes that in order for a computer to really become conscious, it has to look at itself in a reflection and see that it is itself and see that it is a computer that exists. This Sartre believes that you cannot see yourself as an outside object looking in, which is an impure reflection, and it's not really considered a true form of consciousness. Sartre believes that in order to truly exercise self-awareness, one would have to watch itself controlling its movements, which is a difficult task. But if you accomplish this task, it will lead to a free mind and body. This method of self-recognition through seeing your own reflection creates a problem. When you do this, you become a new subject in mind but not in body from the first simpler state of being self-aware. This new subject can only receive validation from an even newer third subject, and that third subject can only receive validation from an even newer fourth subject, and so on and so forth. Jean-Paul Sartre describes this concept as the infinity paradox. If that was a little confusing for you, think of the infinity paradox as seeing your own reflection, then stepping back and seeing yourself look at that reflection. If this is true, how can one truly define consciousness? Sartre believes that this paradox proves that the concept of consciousness cannot be fully understood. The consciousness we have today is solely focused on absolute inwardness that only you can find meaning in. Intelligence is the next step of human civilization. It's currently in its primitive state, but will soon grow into something much more complex at an exponential rate. If it exceeds human level of intelligence, would you consider it to become conscious? In existentialism, the concept of consciousness cannot be fully grasped. So if we are not able to grasp the concept of consciousness, how can we define ourselves as conscious beings? Maybe one day computers will be able to exceed human intelligence and will truly understand what it is like to be conscious. Alright, cut.